All right, so that's sp3 hybridization, but those aren't the only type of hybrid orbitals that we can form. Let's take a look at what happens if instead of combining all 4 orbitals, we just combine 3 of those orbitals, and what we'll end up with is sp2 hybridization. So in sp2 hybridization, instead of combining all 4, we're just combining 2 of the p orbitals with the s orbital. So what we're going to end up with now is 3 hybrid orbitals. And what happens to this last p orbital is nothing at all. We just get it back. So we end up with 1 p orbital completely untouched and 3 hybrid sp2 orbitals. So again, we can think of an example here. So let's take boron, for example. And it starts off with 3 valence electrons. Would you expect to see electron promotion for boron? Yeah, absolutely. If we move up one of our electrons into an empty p orbital, what we're going to see is now we have 3 unpaired electrons that are ready for bonding. So if we hybridize just these 3 orbitals, what we're going to end up with is our sp2 hybrid orbitals. Again, the name is very straightforward. It comes from 1 s and 2 p orbitals, so it will be sp2. And again, you might be thinking, well, why didn't we actually hybridize this 2py orbital? It doesn't actually have an electron in it, so we don't have to worry about whether it's very high in energy or not. We don't care that it's high in energy. What we do care about is the energy of our orbitals that have electrons in them. And if we combined all 4 of the orbitals, then our hybrid orbitals would have more p character to them, so they'd actually be higher in energy. So if we don't have to hybridize one of the p orbitals, we can actually end up with a lower energy situation, because now these sp2 orbitals are 1/3 s character and only 2/3 p character instead of 3/4. So we end up with 3 sp2 hybrid orbitals. So we can think about what would happen here in terms of bonding. And if we think about how to get our bonds as far away as possible from each other, what we're going to have is a trigonal planar situation. So if you picture, for example, BH3, it's going to look like this. All of our electrons are in our bonds. We want to get them 120 degrees away from each other. That's as far away as we can get them. Keep in mind, we do have this p orbital here, and it's coming right out at us. And this p orbital is here, but it's empty. It doesn't have any electrons in it. That's why we don't have to worry about it in terms of getting our electrons as far away from each other as possible. So what we'll have here is a trigonal planar case. And you can see that we only have 3 electrons that are set for bonding. So we'll add 3 hydrogens. And for BH3, we'll get a stable structure here. So remember, boron was one of those exceptions to our Lewis structure rules where it was perfectly happy not having a full octet. So this can tell you why it's so happy with only having 6 electrons around it. All right, so if we think about the BH bond here, again, it's a sigma bond, and we're going to say it's a boron 2 sp2 hybrid orbital interacting with a hydrogen 1s orbital.